Hey Trigoners, welcome to your homework video on Pythagorean Theorem. Most of you have probably seen this already in middle school as a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is your hypotenuse. So hypotenuse is always across from the right angle, right? And it is always your longest side. Some teachers will also show this as leg squared plus leg squared equals hypotenuse squared, because it doesn't really matter which a or b is which leg. All that matters is that your hypotenuse is across from your right angle. So there's many proofs of this. If you're interested, you could go ahead, pop on YouTube, and you guys can find many. But let's show you one based on what you learned yesterday, which was altitude on the hypotenuse theorem. So I'm going to use our little parachute peak shortcut. So let's say, for example, as always, our hypotenuse is c. If I call this side x and this whole side is c, then this side must be c minus x. And I'm going to go ahead and I'm going to start out with my slide squared equals walk times walk. Remember, Pete always lands onto that right angle. So here he is. We have a slide squared equals walk times walk. So to start this, I'd have slide squared, a squared, equals walk, c minus x. And that whole walk is c. Now similarly, I'm going to do the same thing on the other side. B squared, slide squared equals walk times walk. B squared equals walk x times the whole walk. Whole walk is c. Now you're probably seeing why I'm choosing a squared and b squared, because we can see them up in the regular Pythagorean theorem. So if I were to take this a squared and add it to this b squared, watch as I do this. A squared plus b squared. It should equal then what a squared equals. So I'm going to put my a squared in the same spot, c minus x times c, plus what my b squared equals. We said b squared equals x times c. I'm going to write it in alphabetical order. So when I take a quick second to simplify, a squared plus b squared, distribute, I get c squared minus cx plus cx. We can see our cx's subtract out, and I'm simply left with a squared plus b squared equals c squared. This is probably not a proof that you would be asked to repeat, but it's still good to see that it's coming from something that you know. There are so many proofs of this theorem. So let's try this out on something easy here. You're actually soon, this week or next, going to learn something called the Pythagorean triples, and you're going to know quickly that the side length is 13 without any work. But until then, we still have to do a squared plus b squared equals c squared to figure this out. My unknown side here is across from the right angle, which must be my hypotenuse, so I'll call that c. So I'm going to take my two legs, 5 squared plus 12 squared, set it equal to my hypotenuse squared. 25 plus 144 happens to be 169, which is a perfect square. When you square root both sides, you get plus or minus 13. Now we know we can't have a negative side length, so we're going to drop that negative off and leave us with just 13. All right, let's take a look at number 2. If you feel like you could try this one without me, pause the computer, give it a shot, and then unpause, and we can go through it together. All right, so I drew out this picture for us. It says the length of the ramp is 18. Some students get confused. That's actually the length of the part he would be rolling the wheelchair on. And the unknown part from the house to the start of the ramp is down here. Let's just call that x for now. So we're going to assume that this hits the ground at a right angle. And I'm going to go ahead and I'm going to use my Pythagorean theorem. 6 squared plus x squared, hypotenuse this time is 18. I can run through this problem with these big numbers. They're not too hard to handle. I'd get x squared equals 288, square root both sides, and we're not going to pay attention to the plus or minus because I only want the negative side length, or the positive side length. I know you practiced radicals this week, so you should know that the largest perfect square that goes into 288 is 144, and I'm left with a 12 root 2. That's the length of this missing side. This is a fine way to do it, but I actually want to show you something called the reduced triangle principle, which should save you some time as you work through a question like this and make you a little less reliant on a calculator. So let's keep this answer down here just to confirm. So something I noticed at the start of the problem is that both 6 and 18 were divisible by 6. It seems a little strange at first, but watch as I go through this. So I can change this to a 1. 6 over 6 is 1. Plus x squared equals 3 squared. If I do that, I get a 1 plus x squared equals 9. Subtract 1 from both sides, and I'd get x equals the square root of 8. I'm ignoring that plus or minus. We know that this breaks into 4 and 2, so we get x equals 2 root 2, which was not our answer. Well, of course it wasn't our answer because we divided by 6 at the start of the problem. If we divide by 6 at the start of the problem, then we need to multiply our final answer by 6 to get back to the original. Well, 2 times 6 is 12. So 12 root 2 is another way to do this question. The reason that the reduced triangle principle is so nice is because it saves us from reducing large radicals or simplifying large radicals. So I think that is something that you'll want to try as often as possible. So let's go ahead. I want you to actually read through example 3, pause the computer, and see if you can draw this picture on your own. Kelly rollerblading, and then we'll bring it right back together. Okay, so what I have here is Kelly going 7 kilometers north, 5 kilometers east, 4 south, 4 west, 6 south, 12 back to the east, 15 north, and 7 east. All right, so that is her path, and we want to know how far she is from her starting point. So we know the distance between 2 points is a straight line, right? So there is her actual distance. Now, if we can turn this into a triangle, find out how long this piece would be and how long this piece would be, we could actually do the Pythagorean theorem to figure this out. Now be careful, this could be a little bit tricky. Let's look for this horizontal distance first. So if I look straight across, so far it looks like it's 7 long. I'm going to continue from here straight across, but I know that this is 12 long. So 7 plus 12 brings me to here, which takes me to 19 long. The question is, how long is it from here to here? Well, if this whole piece here was 5 and this was 4, that leaves me with a 1 for here. So 7 plus 12 plus 1 leaves me with a side length down here that is 20 long. All right, I'm going to go ahead, I'm going to back this up so I don't have so many lines on my diagram. Whoops. Let's go ahead though and still put these in here and this. So I know this side length of my triangle is 20 long. Drop my right angle in there. All right, this other side's a little trickier. Now stay with me. If this is 7 and this is 4, then from here to here must be 3. And if this whole side length is 6, then this piece below here must be 3, making this little piece here also 3, leaving me with only 12 for this piece. So I'm going to go ahead and make this side length of the triangle 12. Now focus in with me. We're looking at this green triangle, side lengths 20 and 12, and we're trying to find the distance between these 2 points, or the hypotenuse of that triangle. So the Pythagorean theorem would look like this: 12 squared plus 20 squared equals my hypotenuse. We'll call it c squared. And I'm going to go ahead and I'm going to implement that reduced triangle principle on this problem. So if you look at 12 and 20, what number goes into both? That's right, 4. So I'm going to reduce these both by 4. What I get then is a 3 squared plus a 5 squared equals c squared. We get 9 plus 25 equals c squared. 34 equals c squared. So c equals the square root of 34. Now be careful, because you've implemented the reduced triangle principle and you divided both of these by 4. You must multiply your final answer by 4, truly leaving us with 4 root 34. That's the distance, I suppose, in kilometers that Kelly is from her starting point. Same thing on example 4. I want you to go ahead, draw a picture based on your knowledge of rhombuses. Throw your diagonals in there and we'll see if we see any right triangles popping up. So go ahead and do that. Alright, so something that we know about rhombuses is that they're perpendicular bisectors of one another. So they intersect at right angles. If the shorter diagonal is 6, it would bisect into 3 and 3. The longer diagonal is 8, which would be bisected into 4 and 4. We also know that all sides of a rhombus are congruent, so all of those side lengths must be the same. So all I really have to do is find one of them. Let's go ahead, we'll call it C. Here comes Pythagorean theorem again. C is across from the right angle, so it's my hypotenuse. 3 squared plus 4 squared equals c squared. You'll actually be able to do this one again without the Pythagorean theorem once you learn those triples that are coming up soon. But for the sake of Pythagorean theorem, let's do this the full way today. c squared equals 25, so c equals plus or minus 5. I only care about the positive. So I get this side length to be 5, but I have not answered my question yet. It asked for perimeter, so the perimeter of this rhombus is, that's right, 20. All right, all in all, this is really a relatively easy day. And in fact, most of you have probably been exposed to these ideas before. So I'm going to walk you through what could potentially be a very challenging question to see if you can kind of reason through it with me as we go. So truly, I challenge you right now to draw this diagram. Sometimes the hardest part is going from words to a diagram. So pause the computer, see if you can set this up. Okay, so what I have so far is a right triangle. I have the medians drawn from the vertices of the acute angles. I know they're medians, so this point must bisect this side, so maybe I'll call this A and A. The other I've drawn here is also median, so it bisects, this point bisects, so maybe I'll call this B and B. It's a little bit hard to mark this, but one of the medians they said was root 73, so I'm going to go ahead and mark this one as root 73. And I'm going to go ahead and I'm going to mark the other one. What did they say? It was 2 root 13. So I'm going to go ahead and mark this one as 2 root 13. So some of you would look at this and say, I'm absolutely stuck. But when you get to a challenging problem like this, try to zone in on other triangles that could help you out throughout the problem. So I do see a right triangle right here. In this case, this side length down here is 2a. And the other side length is b, so I could use Pythagorean theorem, for example, to say that 2a squared, I'm going to square all of 2a, plus that other side length over there, b squared, equals the hypotenuse, 2 root 13 squared. All right, now be careful. As I square this, make sure you square the 2 and the a, so 2a squared plus b squared. When I square radical, I get 4 times square root of 13 is 13. So this cleans up to 4a squared plus b squared equals 52. I'm going to erase this yellow in here really quick. Well, I'll leave it actually. And I want you to focus in on a new triangle. So maybe you don't know where you're headed yet, but notice here I have another triangle, a right triangle. So I want you to pause the computer, set up Pythagorean theorem for that second triangle, the one in the green. All right, I hope you gave that a shot. What I came up with was a squared plus the other side length, the other leg is 2b, so 2b squared equals the hypotenuse squared. So we'd get an a squared plus a 4b squared equals 73. Now it's time to get a little creative. So we're not used to working with systems that have a squareds and b squareds, but let's go ahead, let's still stack these two equations. So I'm going to go ahead and I'm going to take this equation, I'm going to move it over here, and I'm going to think about how I could use elimination to get rid of one variable. Well, can you look at your b's right now, for example, and think of a way to get rid of your b's? You can multiply the top equation by -4, right? If I wanted to get rid of my a's, I could multiply my bottom equation by -4. So let's actually go ahead and do that. We'll multiply here by -4. When I do that, I went ahead and skipped ahead so you guys can see my a's subtract out. I'd get a -15b squared. Over here on the right side, when I do 52 minus 292, I come up with a -240. If we were to divide both sides by -15,